June 6, 1944, Omaha Beach. Cinematic portrayals often capture the immediate, brutal intensity of ramps descending and soldiers surging onto the contested sands amidst a hail of machine gun fire. Yet, the true, agonizing prelude that Hollywood rarely depicts is the interminable wait. Thousands upon thousands of combatants were confined within claustrophobic steel hulls, circling endlessly offshore for grueling hours, succumbing to the debilitating effects of seasickness, their gazes fixated on the relentless march of time while German artillery crews methodically calibrated their fire upon these predictable, vulnerable patterns. This harrowing scenario was never meant to unfold, and its avoidance of becoming an unmitigated catastrophe stands as a testament to the singular vision of one tenacious boat builder from New Orleans, who daringly resolved a logistical conundrum that the entire United States military establishment had unequivocally deemed insurmountable. Let us journey back to 1941. The American military leadership confronted an alarming strategic dilemma: the daunting mathematical challenge of disembarking a colossal force of 150,000 troops onto hostile shorelines, fortified by what was arguably the most impregnable coastal defenses ever conceived by humanity. Existing methods for amphibious assault were demonstrably catastrophic. The British forces had painfully assimilated this lesson at Gallipoli in 1915, where soldiers, attempting to reach shore in flimsy wooden rowing boats, were mercilessly cut down before their boots ever touched land. By the advent of World War II, the prevailing naval doctrine across most fleets adhered to a rudimentary approach. Gargantuan vessels would anchor at a distance from the coast, then deploy smaller craft via davits. These smaller boats, propelled by oars or rudimentary motors, would then navigate towards the beach, compelling troops to clamber precariously over the gunwales into chest-deep water, encumbered by their weighty 60-pound packs. The operational difficulties proliferated with alarming rapidity. Firstly, the sheer physical mechanics presented an immense hazard. A soldier endeavoring to vault over the side of a landing craft as waves relentlessly battered the vessel against the shore faced a perilous probability, perhaps as high as 60%, of sustaining a debilitating ankle fracture. Secondly, the issue of exposure was critical. For a harrowing 30 seconds, each disembarking soldier became a starkly silhouetted, defenseless target against the backdrop of the sky, a sitting duck for enemy fire. Thirdly, the logistical pace was glacial. Unloading a single company, comprising approximately 120 men, could consume anywhere from a protracted 45 minutes to an agonizing 2 hours, entirely contingent upon the prevailing surf conditions. Fourthly, and perhaps most critically, this method utterly precluded the deployment of essential vehicles, such as agile jeeps, formidable artillery pieces, or battle-winning tanks, the very instruments indispensable for securing and holding ground. These vital assets remained marooned aboard the mothership, as no practical means existed to drive them off a boat into 3 feet of unforgiving water. The British had developed a partial remedy: specialized landing ships equipped with bow doors. However, these were colossal vessels that necessitated beaching themselves directly onto the shore. Once grounded, they became immobile for extended periods, transforming into exceedingly vulnerable, stationary targets for enemy bombardment. The Japanese, for their part, had experimented with their Daihatsu-class landing craft, yet even these designs still mandated that troops leap over the sides, enduring the same hazardous disembarkation. Fundamentally, every naval power across the globe was grappling with the identical, intractable equation: how to ingeniously transform a simple boat into an effective, temporary bridge between vessel and terra firma. Now, the narrative takes a compelling turn. In September 1941, the United States Marine Corps issued a technical specification that appeared to border on the realm of science fiction. They articulated a demand for a vessel capable of transporting 36 fully combat-loaded troops, hitting a beach at maximum velocity, disembarking those troops onto dry sand in less than 10 seconds, then efficiently reversing off the beach and returning for subsequent loads, all within a remarkable 15-minute round trip. The truly audacious requirement, however, was its paradoxical hydrodynamics. It needed a draft shallow enough to navigate treacherous coral reefs with ease, yet simultaneously possessed the inherent stability to withstand rigorous open ocean crossings. Oh, and one final, crucial stipulation. It had to be economically viable enough to be mass-produced in the thousands, and sufficiently straightforward in its operation that even 19-year-old coxswains could skillfully pilot them under the most intense enemy fire. Predictably, every prominent shipyard across America meticulously reviewed these specifications and arrived at the unanimous conclusion: it was utterly impossible. The fundamental laws of naval architecture dictated that the hull shapes required for both an exceptionally shallow draft and robust ocean stability were inherently contradictory. Furthermore, a bow ramp engineered to be structurally sound enough to support the dynamic weight of running troops would be prohibitively heavy. The intricate hydraulic systems, they argued, would inevitably succumb to the corrosive effects of salt water. The comprehensive list of technical objections, meticulously compiled, filled multiple three-ring binders. Yet, amidst this chorus of skepticism, one irrepressible individual from Louisiana persistently appeared at Navy procurement offices, brandishing a crude wooden model and an unwavering grin, adamantly asserting that he had already constructed the impossible contraption. The establishment dismissed him as deranged. It simply turned out he possessed the unique, unconventional ingenuity characteristic of New Orleans. Andrew Jackson Higgins embodied the very antithesis of what military bureaucrats typically admired. He was entirely self-taught, famously loudmouthed, possessed a sartorial style that eschewed properly fitting suits, and harbored the utterly infuriating propensity for being unequivocally correct when every credentialed expert with a university degree declared him mistaken. Born in Nebraska in 1886, Higgins had dedicated 3 decades of his life to designing and constructing shallow draft boats for a diverse clientele, including intrepid oil prospectors, tenacious trappers, and clandestine rum runners who plied the labyrinthine waterways of the Louisiana bayous. While impeccably trained Naval Academy graduates meticulously engineered sleek, ocean-going destroyers, Higgins was pragmatically devising ingenious methods to transport a half-ton engine through 18 inches of murky swamp water without ever snagging on a submerged cypress knee. His enterprise, Higgins Industries, remained entirely off the military's radar until 1938. The Marine Corps had, for many years, been exhaustively testing various prototypes of landing craft, all of which had proven to be abject failures. They had witnessed these experimental vessels run aground 50 yards from shore, or capsize violently in moderate surf, or suffer irreparable damage to their propellers upon encountering hidden sandbars. It was then that a junior officer, recalling a faint rumor, remembered hearing about this eccentric Cajun who crafted boats that, as the local saying went, could run on heavy dew. The Marines, somewhat reluctantly, dispatched a team of observers to New Orleans, primarily to fulfill a bureaucratic formality. Higgins, with characteristic showmanship, loaded them into his latest swamp boat, a vessel he christened the Eureka, and proceeded to execute a breathtaking demonstration. He drove it at full throttle directly onto a mudflat, spun it around with the agility of a high-performance sports car, and then effortlessly motored back into the deeper channel. The astounded observers immediately cabled Washington with a terse, urgent message. You need to see this immediately. What rendered Higgins's design truly revolutionary, and consequently incited the disdain of conventional shipbuilders, was his audacious disregard for established naval architectural principles. Standard doctrine dictated that a boat's bow should be sharply pointed to efficiently cleave through water. Higgins, conversely, fashioned a bow that resembled a snow shovel, flat, broad, and angled distinctly upward. Traditional wisdom also mandated a deep keel for optimal stability. His boats, however, possessed virtually no keel at all, merely a shallow, semi-tunnel configuration ingeniously protecting the propeller. The very form of the hull appeared fundamentally incorrect, felt inherently wrong to anyone steeped in the tenets of conventional marine engineering. Yet, in the challenging environment of the Louisiana swamps, it functioned with an almost magical efficacy. The military's initial response was a potent blend of dismissive contempt and deep-seated suspicion. Engineers from the esteemed Bureau of Ships meticulously authored lengthy technical papers, painstakingly detailing precisely why the Eureka's unconventional design flagrantly violated fundamental hydrodynamic principles. They vehemently argued that the flat bow would inevitably generate excessive drag, thereby impeding speed and efficiency. The shallow draft, they contended, would render the vessel uncontrollable in strong currents, and the innovative protected propeller tunnel, they predicted, would lead to severe cavitation problems. Higgins, ever the pragmatist, extended an invitation for them to witness demonstrations firsthand in New Orleans. They politely declined, citing nebulous budget constraints, a diplomatic refusal that essentially translated to, "We are not squandering government funds on nonsensical swamp boat experiments when reputable shipyards are diligently developing proper, conventional landing craft." Nevertheless, the Marine Corps steadfastly continued to champion Higgins's design, for they were the ones who would ultimately face the brutal reality of storming enemy beaches, and they possessed an intuitive understanding that the death-bound admirals conspicuously lacked. In April 1941, after persistent advocacy, the Navy finally consented to conduct competitive trials in Norfolk, Virginia. For distinct shipyards presented their respective designs. 3 of these contenders hailed from venerable maritime companies, each boasting gilt-edged reputations and a long history of conventional naval construction. Higgins, in stark contrast, arrived with 3 of his boats unceremoniously strapped to a barge. He presented no elaborate blueprints, only the tangible, functional hardware itself. The official evaluation criteria were comprehensive, encompassing seaworthiness, speed, maneuverability, and durability, but the paramount factor, the ultimate litmus test, was the vessel's unequivocal ability to efficiently extract itself from a beach after landing. The results of these trials were unequivocally lopsided. Higgins's innovative boats consistently struck the beach at a blistering 9 knots, smoothly rode up onto the sand, backed off in an astonishingly brief period of under 30 seconds, and repeated this flawless maneuver 20 times without a single instance of propeller fouling or hull damage. The competition, by comparison, fared disastrously. One rival boat buried its bow inextricably in the sand and proved utterly incapable of dislodging itself. Another's propeller shattered irrevocably upon its very first grounding. The third managed a single successful beaching and extraction before it began taking on water, signaling imminent failure. By the second day of trials, Navy observers were discreetly, but urgently, rewriting established procurement protocols. By the third day, Andrew Higgins had secured a monumental contract for 1,500 boats, and remarkably, he still hadn't unveiled his truly audacious, paradigm-shifting concept. The Eureka boat, in its initial form, had effectively resolved precisely half of the complex problem: the efficient ingress to and egress from the beach. However, troops were still obliged to clamber perilously over the vessel's sides, and there remained absolutely no practical means to drive a jeep or any other vehicle directly out of it. Higgins was acutely aware of this critical deficiency. For 2 years, he had been meticulously sketching potential solutions, often in the margins of napkins, but every design invariably encountered the same insurmountable obstacle: the immutable laws of physics. Incorporating a ramp at the bow necessitated hinges, and hinges inherently represented a critical weak point precisely where the boat experienced the most intense structural flexing. The forces involved were nothing short of absurd. Envision a robust steel plate, 4 feet wide and 8 feet long, tasked with supporting the combined weight of 6 fully equipped men, each weighing approximately 250 pounds, while the boat pitched violently in 3-foot swells. This translates to a staggering 1,500 pounds of dynamic load bouncing rhythmically on a hinge every 2 seconds. Engineers, applying rigorous calculations, unequivocally predicted that such immense stress loads would inevitably snap any hinge mechanism within a mere week of continuous saltwater operations. Then, in late 1941, a pivotal moment arrived when a discerning Marine Corps officer named Victor Krulak presented Higgins with a single photograph that irrevocably altered the trajectory of his design. Krulak had served as an observer in Shanghai in 1937, witnessing firsthand the Japanese assault on Chinese positions along the Yangtze River. The photograph vividly depicted a Japanese Daihatsu landing craft featuring a ramp positioned at the bow, rather than requiring troops to disembark over the sides, a genuine ramp. Higgins reportedly stared intently at that image for perhaps 10 seconds, then allegedly uttered an unprintable expletive, conceding that the Japanese had grasped the fundamental concept correctly, but had executed it poorly, as their ramp still compelled troops to wade through ankle-deep water upon disembarking. It was at this precise juncture that Higgins's profound expertise in swamp boat design shifted into overdrive. The Japanese design incorporated a ramp that simply angled downward into the water. While this might have been adequate for the placid conditions of calm rivers, it proved utterly useless in the turbulent environment of surf zones, where every incoming wave could instantaneously alter the water depth by 2 feet or more. Higgins, drawing upon his years of practical experience, ingeniously realized that the ramp could not merely drop. It had to execute a dual motion, dropping and simultaneously extending the hull forward, thereby creating a solid, continuous bridge directly from the boat's deck to the dry expanse of the beach. This geometric solution sounds deceptively simple in theory, but its practical implementation presented immense engineering challenges. The ramp itself needed to maintain the identical 45-degree angle of his existing bow design. When raised, it would seamlessly integrate as the boat's bow, forming a completely watertight continuation of the hull. When lowered, it had to lock into a position that was both perfectly flat and sufficiently stable to permit a 5,000-pound Jeep to drive across at its speed, without exhibiting more than a half-inch of flex. To rectify this issue, his methodology embraced an unadulterated form of mechanical strength. This involved the strategic deployment of 2 formidable hydraulic cylinders, operating in concert with robust steel cables, further augmented by a system of manual chains as a contingency against potential hydraulic failure. The very ramp itself was meticulously constructed from a 1/4-inch steel plate, its structural integrity enhanced by a latticework of I-beams expertly welded to its underside. Though undeniably cumbersome, this substantial mass proved advantageous. Upon impacting sandy terrain, its inherent momentum and considerable weight ensured its steadfast anchoring. The hinge mechanisms were far from delicate fulcrums. Rather, they constituted colossal pin assemblies, each measuring a full 4 inches in diameter, akin to those employed in the construction of a drawbridge. While acknowledging their susceptibility to failure, their design guaranteed sufficient operational longevity to serve their critical purpose. Furthermore, Higgins ingeniously engineered the entire apparatus to permit a crew to effectuate the replacement of a compromised hinge within a mere 20 minutes, utilizing only a sledgehammer and a cheater bar. The inaugural prototype materialized in May of 1942. Higgins christened it the LCDP, an acronym signifying Landing Craft, Vehicle, Personnel. The military, however, colloquially referred to it as the Higgins boat, a designation Andrew personally disfavored, preferring that due recognition be accorded to his dedicated engineers. The Marine Corps transported this innovative craft to Solomon's Island, Maryland, for rigorous testing. The evaluation contingent meticulously loaded it with a full platoon of soldiers, alongside a jeep, an unprecedented feat for any extant landing craft globally. They then propelled the vessel towards a designated beach and observed its performance with keen interest. The ramp descended smoothly, allowing the jeep to disembark in a mere 4 seconds. The troops followed, exiting in an additional 6 seconds. The ramp then retracted, and the craft reversed into deeper waters, completing the entire sequence from grounding to withdrawal in a swift 13 seconds. The presiding officer, profoundly impressed, transmitted a communique to Washington. Specifications met. Recommend immediate mass production. Within 3 weeks, Higgins secured a contract for 10,000 units. Despite lingering doubts within the Pentagon regarding the design's combat efficacy, their dire circumstances compelled them to undertake this calculated gamble. Years subsequent to the cessation of hostilities, Dwight D. Eisenhower articulated a sentiment that, by all accounts, merits inscription in perpetuity. Andrew Higgins is the man who won the war for us. If Higgins had not designed and built those landing crafts, we never could have landed over an open beach. The whole strategy of the war would have been different. Emanating from a 5-star general who orchestrated the most extensive amphibious invasion in recorded human history, this declaration transcends mere hyperbole. It represents a profound acknowledgement. Yet, a deeper examination of the empirical data reveals a reality even more astonishing than the prevailing legend. Guadalcanal, on August 7, 1942, marked the initial significant trial of the Higgins boat under authentic combat conditions. The 1st Marine Division faced the formidable task of disembarking 11,000 troops onto beaches staunchly defended by 2,800 Japanese soldiers, who had enjoyed several months to meticulously prepare their defenses. Pre-war military doctrine had estimated that such an operation would necessitate a protracted period of 14 to 18 hours to successfully land all personnel and their requisite equipment. The actual execution, however, was dramatically swifter. A mere 4 hours and 17 minutes elapsed from the moment the first boat touched the sand to the final rifle company establishing its defensive positions. Marine logistics officers, incredulous, suspected their stopwatches were malfunctioning. They radioed the offshore transports, seeking corroboration. Confirmed troop counts. This can't be right. The transports unequivocally confirmed. Every man accounted for, plus 73 vehicles that doctrine said couldn't be landed on day 1. The mechanical ingenuity underpinning this extraordinary efficiency was truly remarkable. A solitary Higgins boat possessed the capability to complete the arduous beach-to-transport cycle in a mere 11 to 15 minutes, contingent upon the distance involved. This comprehensive cycle encompassed grounding, expeditious unloading, precise reversing, swift return transit, and efficient reloading. This performance stands in stark contrast to the British landing craft deployed at Dieppe 3 weeks later, which registered an average of 32 minutes per cycle and, critically, often proved incapable of self-extraction, resulting in numerous vessels becoming stranded as the tide receded. At Guadalcanal, the Marine forces deployed 87 Higgins boats in the initial assault wave. A straightforward mathematical calculation illustrates their impact. 87 boats completing 4 trips per hour translates to an astounding 348 boat loads delivered every 60 minutes. Each individual boat was designed to transport either 36 men or one vehicle accompanied by its crew. Performing the requisite arithmetic reveals an impressive operational tempo exceeding 12,000 personnel equivalent movements per hour. The primary constraint, it became clear, was not the capacity of the boats themselves, but rather the speed at which they could be loaded from the transport ships. Tarawa, in November 1943, presented a crucible where the legendary 3-minute claim was rigorously tested under truly nightmarish circumstances. The naval hydrographic charts proved erroneous. The tide was a full 18 inches lower than projected, and a formidable coral reef extended an unforgiving 500 yards from the shoreline. Larger landing ships consequently grounded out, rendered immobile, and incapable of further advance. Yet, the Higgins boats, with their exceptionally shallow draft of only 3 feet, glided effortlessly over the treacherous reef, as if it presented no impediment whatsoever. Wave after relentless wave, arriving every 3 to 4 minutes, saw another boat impact Red Beach. The Japanese defenders had meticulously pre-sighted their machine guns and mortars on the waterline, anticipating slow-moving, vulnerable targets. Instead, they were confronted with an unrelenting conveyor belt of advancing Marines. The Marines endured horrific casualties, with over 1,000 fatalities within 76 hours. Nonetheless, their advance was unceasing, sustained by the continuous operation of the boats. Japanese commander Keiji Shibasaki had audaciously boasted that it would require 1,000,000 men and a century to subjugate Tarawa. The Marines accomplished this formidable task in a mere 3 days, largely due to the Higgins boats' unparalleled ability to deliver reinforcements with a rapidity that outpaced the defenders' capacity to inflict attrition. Sicily, in July 1943, witnessed Operation Husky, a monumental undertaking involving an impressive 2,590 landing craft of various classifications, simultaneously targeting 26 distinct beaches. Higgins boats constituted approximately 1,400 of this formidable armada. The operational tempo was executed with surgical precision. Boats grounded, discharged their cargo, withdrew, and returned with such an established rhythm that beach masters found themselves orchestrating arrivals with the meticulous coordination of air traffic controllers. Some individual boats completed an astounding 14 round trips within the initial 12 hours. Crews toiled beyond the point of exhaustion, navigating by an innate sense of direction and loading by ingrained muscle memory. When Navy analysts subsequently compiled their exhaustive after-action reports, they discovered that the average Higgins boat deployed at Sicily had successfully delivered 468 troops or 23 vehicles over a continuous 3-day operational period. Multiplying this efficiency across the 1,400 boats underscores precisely why the German forces proved incapable of reinforcing their positions with sufficient alacrity to mount an effective counterattack. Then arrived Normandy on June 6, 1944. Over 1,500 Higgins boats comprised the initial assault waves across 5 designated beaches. Utah Beach meticulously recorded boat arrivals occurring every 3.2 minutes during its peak operational hours. Omaha, conversely, was a maelstrom of unbridled chaos. German defenses proved to be far more formidable than intelligence assessments had initially predicted. Yet, Even amid such ferocious resistance, the boats maintained their relentless advance. This unwavering persistence, fueled not solely by individual heroism, but by sheer volume, ultimately fractured the German defensive lines. One could conceivably neutralize the initial wave, and even the subsequent one, but the eighth wave, the 15th? The Higgins boats rendered such sustained persistence a tangible reality. The Japanese military possessed the photographic evidence. They had observed their own Daihatsu landing craft, which had pioneered the concept of the bow ramp back in the 1930s. This raised a perplexing question that persistently vexed Allied intelligence officers throughout the Pacific Campaign. Why had they not developed a vessel as profoundly effective as the Higgins boat? Each time American forces successfully captured a Japanese-held island, they invariably discovered landing craft that were almost functional, yet consistently fell short in crucial, fundamental aspects. The answer to this enigma unveils a fascinating insight into the profound influence of engineering philosophy on the conduct of warfare. The Daihatsu-class landing craft, first deployed in 1937 during the Second Sino-Japanese War, bore a superficial resemblance to the Higgins design. It featured a bow ramp, possessed a shallow draft, and was theoretically capable of beaching and retracting. However, Japanese engineers had meticulously optimized their design for an entirely different set of environmental conditions. Their primary operational theaters were along the calm waterways of rivers and protected coastal areas in China and Southeast Asia, regions where tidal patterns were predictable, beaches could be thoroughly surveyed in advance, and operations generally occurred in relatively sheltered waters. Consequently, the Daihatsu incorporated a deeper V-hull, which enhanced its efficiency and speed in these placid conditions. This very design choice, however, rendered it utterly inadequate in surf. When waves impacted that V-hull at an oblique angle, the boat would uncontrollably skew sideways, sometimes even capsizing entirely. The ramp mechanism itself eloquently narrated the entire narrative. Japanese designers opted for a lightweight ramp that deployed into the water at a precipitous angle. This configuration was perfectly adequate for a riverbank where the water depth was a mere 6 inches. However, upon encountering a beach with 2-foot surf, disembarking troops were compelled to wade through knee-deep water, thereby forfeiting crucial speed, compromising the element of surprise, and exposing themselves to enemy fire. Marines who captured and tested Daihatsu craft at Guadalcanal delivered a scathing assessment. Ramp does not extend hull line. Vehicle operation impossible in surf conditions. Extraction from beach inconsistent due to underpowered engines and hull design. Herein lay the more profound miscalculation. The Japanese leadership never fully comprehended that Higgins's seemingly ungainly, blunt bow was not a design concession but, in fact, the very essence of its genius. That distinctive snow shovel-like configuration enabled the boat to ride up onto the beach at speed, leveraging its momentum to ascend the sandy incline until the ramp could descend directly onto dry ground. The sharper bow of the Daihatsu, conversely, would invariably dig into the sand and become firmly launched. Japanese crews attempted to compensate for this inherent flaw by approaching the shore at a reduced speed, an adjustment that inadvertently afforded defenders more precious time to accurately aim their weapons. At Tarawa, American forces discovered abandoned Daihatsu craft that had successfully beached, but were subsequently unable to reverse off. Their propellers had either struck coral formations or their hulls had settled too deeply into the sand, effectively transforming them from transportation vessels into stationary bunkers. The Imperial Japanese Navy did eventually attempt to directly replicate the Higgins boats. In 1944, Japanese engineers meticulously examined captured LCVPs from the Philippines and subsequently produced detailed specifications for a domestic version. By this juncture, however, Japan's industrial capacity was in a state of rapid collapse. They possessed the blueprints, but critically lacked the necessary manufacturing infrastructure to mass-produce complex hydraulic systems. More significantly, they were devoid of the requisite shipyard workforce. Higgins Industries famously employed semi-skilled laborers, who could be trained to weld hull sections within weeks, not years. Japan's entrenched traditional shipbuilding culture, in contrast, relied heavily on master craftsmen, a system that simply could not scale to meet the urgent demand for thousands of boats immediately. A poignant Japanese naval assessment from late 1944 offers a melancholic insight into wartime industrial philosophies. The report, penned by a perceptive engineering officer, observed that American landing craft, while appearing rudimentary, embodied profoundly effective design principles that intentionally sacrificed aesthetic refinement for the twin virtues of mass manufacturability and superior performance in turbulent waters. He further noted the remarkable ease with which these U.S. vessels could be operated by even inexperienced crews, attributing this to their straightforward controls and a hull design that was remarkably forgiving of operator missteps. In stark contrast, Japanese landing craft demanded the seasoned expertise of highly skilled coxswains for proper navigation. The officer's concluding reflection was stark. Japan had fixated on the pursuit of unparalleled quality, whereas the Americans had grasped that ultimate victory in the conflict would be determined by sheer numerical advantage. This fundamental philosophical chasm, he posited, could not be bridged by a mere replication of hull shapes. Indeed, by 1945, Japanese forces across the Pacific were still reliant on Daihatsu craft, which necessitated troops waiting ashore, while every American amphibious assault had evolved into a textbook demonstration of mechanized operational efficiency. Though the Japanese had pioneered the innovative bow ramp, they tragically failed to unlock its transformative potential. Higgins, however, seized upon this concept, fully comprehended its inherent utility, and meticulously re-engineered it from foundational principles. This was far more than mere imitation. It represented a profound evolutionary leap in design. August 7, 1942, marked the fateful dawn of the Guadalcanal campaign, where theoretical military planning was poised to collide head-on with the brutal realities of coral reefs, relentless Japanese machine gun fire, and the sheer pandemonium that renders even the most meticulously crafted engineering textbook seem quaint. The Higgins boat, prior to this crucible, had demonstrated impeccable performance during tranquil water trials conducted at Norfolk and Solomon's Island. Yet, these were meticulously controlled environments, featuring precisely surveyed beaches and, crucially, an utter absence of hostile engagement. Now, 87 of these vessels were converging upon Lunga Point, bearing the vanguard of the 1st Marine Division, and a profound uncertainty permeated the air regarding the design's capacity to withstand the unparalleled rigors of actual combat stress. The inaugural challenge immediately presented itself: the formidable reef. While pre-invasion reconnaissance had indeed identified its presence, intelligence analysts had critically underestimated both its expansive reach and the dangerously shallow depths it created. Larger landing ships, specifically the LSTs, which were purpose-built for the transportation of tanks, found themselves irrevocably grounded a full 400 yards from the shoreline. Their deployment ramps descended into 4 feet of water, a depth that rendered the disembarkation of tanks impossible without the immediate drowning of their vital engines. In stark contrast, the nimble Higgins boats, drawing a mere 3 feet when fully loaded, gracefully skimmed over the treacherous reef with mere inches to spare. Coxswains recounted the unnerving sensation of their hulls scraping against the coral, accompanied by the sickening, grinding sound. Yet, remarkably, the boats maintained their forward momentum. This extraordinary resilience was a direct testament to Higgins' meticulous over-engineering of the hull bottom, which featured robust double-riveted seams and heavily reinforced keel guards, a design philosophy specifically predicated on the assumption that these vessels would inevitably encounter unforgiving obstacles. This almost paranoid approach to structural integrity proved instrumental in salvaging the critical initial phase of the landing within the first 30 minutes. The second formidable challenge arose from the unexpected composition of the beach itself. The sand at Lunga Point bore no resemblance to the firm, compacted variety found on controlled test ranges. Instead, it comprised loose, volatile volcanic material that yielded unreliably under weight. Upon impact at full velocity, the bows of the initial wave of boats dug in far deeper than anticipated, with some embedding themselves up to 18 inches before their forward momentum was completely arrested. A wave of panic initially swept through the crews, who feared they were irrevocably stuck. It was at this critical juncture that the ramp hydraulics engaged. The substantial weight of the descending ramp, surprisingly, served to re-level the boat, effectively redistributing its mass. Troops then swiftly disembarked, lighting the vessel, while coxswains deftly engaged the engines in reverse. The vast majority of boats successfully extracted themselves in under 40 seconds. A select few required a second attempt, backing off at a slight angle to break the stubborn suction. One boat commander later recounted the extraordinary feat of reversing, repositioning, and intentionally grounding his vessel 3 additional times to unload subsequent waves of troops. Throughout this arduous ordeal, the hull absorbed the relentless abuse without exhibiting a single crack or structural failure. The third significant obstacle manifested in the form of unrelenting enemy fire. It was here that the inherent mechanical simplicity of the Higgins boat design yielded unforeseen and profound advantages. Japanese defenders relentlessly targeted the incoming vessels with a barrage of mortars and machine guns. Bullets easily perforated the plywood gunwales, a material choice Higgins had made for the boat's sides to conserve precious weight, reserving steel exclusively for the ramp and the hull bottom. Troops instinctively crouched behind the sturdy bow ramp for protection, a strategy that proved remarkably effective because the quarter-inch steel barrier was capable of deflecting rifle rounds. However, the truly critical aspect of the design emerged when hydraulic lines were severed by shrapnel, an unfortunate occurrence that afflicted 11 boats in the initial assault wave. In such instances, crews could seamlessly switch to a manual chain system, requiring 2 men to crank handles. While the ramp's descent was slower, taking 18 seconds instead of the customary 6, it still descended. This ingenious built-in redundancy, a primary hydraulic system complemented by a robust manual backup, ensured that even battle-damaged boats remained fully functional and capable of completing their vital missions. The fourth, and perhaps most daunting, problem was the issue of sustainment. Over the ensuing 3 days, those 87 boats operated continuously, a testament to their rugged construction and the ingenuity of their crews. Remarkably, there were no dedicated maintenance facilities or readily available replacement parts. Instead, crews performed ad hoc field repairs between runs. Resourcefulness was paramount. They resorted to using seawater as an emergency coolant when freshwater supplies inevitably dwindled, and bullet holes were hastily patched with tar and canvas. In one particularly striking incident, a boat suffered the complete loss of its hydraulic system when a mortar fragment obliterated the pump, yet its determined crew operated it manually for 2 full days, completing an astonishing 23 trips, until a repair ship finally arrived. Higgins had meticulously engineered every major component to be replaceable with nothing more than basic hand tools and sheer brute force. A damaged propeller? A spare could be swiftly swapped in a mere 20 minutes. A cracked ramp hinge? A backup plate could be bolted on, allowing the boat to continue its mission. The after-action reports from Guadalcanal were so extensive they filled 3 comprehensive binders. Navy maintenance teams conducted meticulous inspections of every boat after the first week of operations. They identified stress fractures, worn bearings, and corroded fittings, but crucially found no catastrophic structural failures. The average boat had endured an astounding 31 groundings, sustained multiple direct hits, and operated continuously in corrosive saltwater environments without formal maintenance, yet still retained an impressive 87% mission capability. Engineers had initially projected a grim 40% failure rate within the first 48 hours of combat operations. The actual failure rate, however, was a mere 9%, with most of those instances attributed to boats sustaining direct hits from heavy artillery. Guadalcanal did more than just validate the efficacy of the Higgins boat. It unequivocally demonstrated that an unglamorous, overbuilt, and inherently idiot-proof design profoundly outperforms elegant engineering when human lives are at stake. Here is where the narrative takes an astonishingly unhinged turn. In December 1941, Higgins Industries was a modest regional boat shop, employing a mere 75 individuals, and producing perhaps a dozen craft each month. By December 1944, it had undergone a breathtaking metamorphosis, emerging as the largest private employer in Louisiana, boasting a workforce exceeding 20,000, operating 7 sprawling plants that collectively span 30 city blocks, and delivering an astounding 700 boats on a monthly basis. This was not merely scaling production. It was, by all accounts, an act of industrial sorcery. Andrew Higgins orchestrated this extraordinary feat by systematically flouting every manufacturing convention that the government had, until then, deemed sacrosanct. The military's procurement office adhered to very specific, entrenched notions regarding shipbuilding. One was expected to engage highly trained shipwrights, who had dedicated years to mastering their craft. Vessels were to be constructed individually, from inception to completion, with the same dedicated crew overseeing each project, and rigorous quality control was to be maintained, with inspectors meticulously signing off at every stage. Higgins, upon reviewing this established model, essentially dismissed it as adorable, but utterly impractical given the urgent imperative to produce 20,000 boats within 3 short years. His unspoken challenge was clear. So watch this. He audaciously borrowed a revolutionary manufacturing technique from Henry Ford, one that the entrenched maritime industry considered outright heresy: assembly line production. Boats don't move through factories, traditional shipbuilders adamantly insisted. Higgins, with characteristic defiance, made the move anyway. He ingeniously deconstructed the complex LCDP construction process into 14 distinct major subassemblies. Station 1 was dedicated to the precise fabrication of the bow ramp and its intricate hydraulic systems. Station 2 focused on the meticulous construction of hull sections. Station 3 expertly managed the integration of engines and drive systems. Workers, regardless of their background, specialized in a single, repeatable task, perhaps welding a specific seam, riveting a particular joint, or wiring one distinct electrical system. A young individual from rural Louisiana, who had never once glimpsed the ocean, could be trained to execute a flawless hull seam weld in just 2 weeks. The traditionalists, predictably, raised a furious outcry, vehemently asserting that such methods would inevitably yield inferior vessels. Higgins's decisive response was to extend an invitation to Navy inspectors, challenging them to rigorously test random boats directly off the production line. The results were irrefutable. The recorded failure rate was an astonishingly low 2.1%, a figure that surpassed the quality achieved by traditional shipyards still producing bespoke, one-off vessels with their revered master craftsmen. The workforce itself underwent a profound and revolutionary transformation under Higgins's leadership. He adopted an entirely inclusive hiring policy, welcoming anyone capable of wielding tools: women, black workers, elderly men who were beyond draft age, and even teenagers seeking summer employment. In the conservative social climate of 1940s New Orleans, such practices were profoundly radical. Indeed, Higgins's company integrated its factories years before the United States military itself began to desegregate its units. Black and white workers labored side by side on the same assembly lines, shared meals in the same cafeterias, and utilized the same restroom facilities. Higgins's rationale was rooted in pure, unadulterated pragmatism. "I don't care if they're purple with pink polka dots. Can they weld?" Yet, the societal impact of this forward-thinking approach was undeniably profound. By 1943, black workers constituted an impressive 18% of his total workforce, and women accounted for a substantial 40%. Rosie the Riveter was not merely an iconic poster figure in New Orleans. She was a tangible, living force, actively constructing the vital boats that would ultimately secure victory in the global conflict. The tempo of production at Higgins Industries was nothing short of relentless. In June 1944, the very month of the pivotal D-Day invasion, the company delivered an astonishing 737 landing craft. This staggering output translated to an average of 24 boats being completed every single day, effectively one new vessel every 60 minutes, achieved through continuous, round-the-clock operations across 3 shifts. The plants never ceased their activity. The brilliant arcs of welding torches illuminated the night sky, resembling an incessant electrical storm. Workers routinely clocked 60-hour weeks as standard, with demanding 80-hour weeks becoming commonplace in the periods leading up to major invasions. The company, recognizing the importance of worker welfare, paid premium wages, offering $1.20 per hour when the national average stood at merely 65 cents. Higgins possessed a shrewd understanding that exhausted and financially strained workers would inevitably produce substandard boats. Conversely, he knew that well-compensated and highly motivated personnel were essential for maintaining stringent quality standards, while simultaneously achieving almost impossibly ambitious production quotas. Ultimately, the primary constraint on this prodigious output shifted from labor availability to the procurement of raw materials. A single LCVP demanded a precise inventory: 1.2 tons of steel plate, 80 feet of hydraulic line, 340 rivets, 15 gallons of marine paint, and one 225 horsepower gray marine diesel engine. Multiplying these requirements by the monthly target of 700 boats revealed an immense logistical challenge. 840 tons of steel, 56,000 feet of hydraulics, and 238,000 rivets were needed every single month, with absolute punctuality and no exceptions. Higgins, ever the pragmatist, established direct, unmediated relationships with major steel mills in Pittsburgh, rubber manufacturing plants in Akron, and engine producers in Detroit. He frequently bypassed the sluggish military logistics channels entirely, when procurement officers proved too slow, sometimes even acquiring essential materials on the private market at a higher cost, solely to maintain his rigorous delivery schedules. The Pentagon initially harbored a deep disdain for this unconventional, cowboy, approach to supply chain management, a sentiment that persisted only until they recognized that Higgins's boats consistently appeared exactly when promised, a testament to his unorthodox yet remarkably effective methods. Exactly when promised. By the cessation of hostilities, Higgins Industries had achieved an extraordinary production tally of 20,940 vessels, a diverse fleet encompassing not only the ubiquitous LCVPs, but also more substantial LCMs, Agile PT boats, and various other specialized maritime conveyances. This monumental output surpassed the combined manufacturing efforts of all other American boat builders during the same period, solidifying the company's critical role by accounting for a staggering 92% of the Navy's entire landing craft flotilla. However, the fortunes of this industrial powerhouse turned abruptly with Japan's surrender in August 1945, when 12,000 additional boat orders placed with Higgins were instantly rescinded. Within a mere 6 months, the company's once booming workforce plummeted from an impressive 20,000 individuals to a sparse 800. This formidable industrial empire, which had ascended with meteoric speed, collapsed with equal alacrity. Yet, the legacy of those 20,000 vessels was already indelibly etched, having profoundly reshaped the very narrative of military history. The hallowed sands of Omaha Beach, at precisely 6:30 hours on June 6, 1944, marked the commencement of arguably the most renowned 6 hours in the annals of amphibious warfare. Throughout this pivotal period, Higgins' boats served as the indispensable connective tissue, meticulously weaving together the fabric of the entire monumental invasion. When one observes those evocative, grainy archival films or the meticulously crafted Hollywood reenactments, one is witnessing the culmination of a multifaceted triumph, the painstaking evolution of design, an unparalleled manufacturing miracle, and the rigorous crucible of combat testing. Simultaneously, these images reveal the foundational blueprint that would dictate the execution of virtually every amphibious assault for the ensuing 80 years, extending its influence right down to contemporary operations. The statistical data emerging from the Normandy landings are staggering in their sheer scale, a magnitude that only truly resonates upon a deliberate, reflective consideration of the immense logistical complexities involved. The initial assault waves alone deployed 1,089 Higgins boats across 5 distinct landing zones. At Omaha Beach in isolation, a remarkable 293 LCVPs executed the perilous journey from the larger transport ships to the embattled shore. Each individual boat performed an average of 4.7 cycles within the initial 12-hour period. This translates into an astonishing 1,377 discrete beach landings at that singular location within just half a day. To fully grasp the intensity, one must envision a landing craft making landfall, discharging its vital cargo, and then extracting itself from the shore approximately every 31 seconds during the peak hours of the assault. The German defenders were not merely contending with individual soldiers. They were confronting a sophisticated mechanical apparatus engineered to overwhelm them through relentless, systematic repetition. Even amid significant material losses, with 34 boats tragically destroyed at Omaha by formidable underwater obstacles, insidious mines, and devastating artillery fire, the relentless operational tempo remained barely impeded, sustained by a continuous, unwavering influx of replacement vessels. The strategic doctrine that definitively emerged from the crucible of Normandy quickly attained an almost canonical status. Modern amphibious operations, even today, continue to adhere fundamentally to the established Higgins template: successive echelons of landing craft, precisely orchestrated timed intervals for deployment, a continuous and uninterrupted flow of resupply, and the direct debarkation of essential vehicles onto contested beaches. The United States Marine Corps' contemporary landing craft air cushion, LCC, those futuristic-looking hovercraft that often appear to belong to the realm of science fiction, despite their advanced technological profile, perform an identical operational function to the original LCVP. While undeniably swifter and considerably more sophisticated in their engineering, their core mission remains precisely the same: to transport military personnel and vital equipment from larger naval vessels to the shoreline, then promptly disengage to repeat the task with unwavering efficiency. Even the Chinese People's Liberation Army Navy meticulously scrutinized historical Normandy footage when conceptualizing and designing their Type 726 landing craft, specifically for potential future operations around Taiwan. The intrinsic underlying geometry of the landing craft concept has, fundamentally, remained unchanged: a safeguarded approach path, a forward-deployed bow ramp for rapid discharge, and swift egress capabilities. However, a crucial aspect frequently overlooked amidst the widespread celebrations of D-Day is the profound and far-reaching impact of the Higgins boat, which extended significantly beyond the European theater. Across the vast and unforgiving expanse of the Pacific, the strategic island-hopping campaign functioned, in essence, as an immense, continuous Higgins boat conveyor belt, stretching over an incredible 5,000 miles and encompassing pivotal engagements at Guadalcanal, Saipan, Peleliu, Iwo Jima, and Okinawa. Every single one of these complex and arduous operations relied intrinsically on these robust, shallow-draft workhorses, which possessed the unique capability of navigating treacherous coral reefs that would have rendered conventional, deeper-draft landing ships utterly immobile. During the brutal battle for Iwo Jima in February 1945, United States Marines successfully disembarked an impressive 30,000 troops within the initial 48 hours, utilizing 482 Higgins boats. These vessels operated on shores composed of volcanic ash so exceptionally loose and fine that military vehicles would frequently sink up to their axles. The boats, and more importantly, their skilled coxswains, demonstrated remarkable adaptability. Crews rapidly learned to modify their techniques, approaching the beach at elevated velocities, and cleverly utilizing the boat's momentum to climb above the most challenging, softest sections of sand. This inherent operational flexibility, the invaluable capacity to adjust tactics and methods based on unpredictable environmental conditions, stemmed directly from the fundamental simplicity and robust nature of the boat's original design. Andrew Higgins, the visionary behind these transformative vessels, passed away in 1952, a mere 7 years subsequent to the cessation of hostilities, largely consigned to historical obscurity and in dire financial straits. His industrial enterprise, despite its wartime triumphs, proved tragically unable to successfully pivot to a peacetime manufacturing model. Military procurement agreements, which had fueled his prodigious output, evaporated with the end of the war, and he had committed every conceivable resource, leveraging everything he possessed, to fulfill the demanding wartime production quotas, leaving no fiscal reserves whatsoever. The very individual whom President Eisenhower himself lauded for his pivotal role in securing victory spent his declining years embroiled in legal battles with relentless creditors. There stands no grand Higgins memorial on the prestigious National Mall, nor has an aircraft carrier ever borne his distinguished name. The vast majority of American citizens, sadly, remain unfamiliar with his identity. Nevertheless, anyone who has witnessed cinematic records of amphibious beach assaults, whether from the global conflicts of World War II, the Korean War, the Vietnam War, the Gulf War, or the more recent conflicts in Iraq, has undeniably encountered the profound and persistent manifestation of his genius. The contemporary United States military continues to deploy landing craft that are direct lineal descendants of Higgins's innovative design. For instance, the Landing Craft Utility, LCU, can meticulously trace its genealogical progression through 7 distinct evolutionary stages, directly back to the original LCVP. When Marine Corps personnel conduct rigorous amphibious training maneuvers at renowned facilities, like Camp Pendleton or Quantico, they are, in essence, executing operational protocols formulated in 1943, procedures that were intrinsically predicated upon the inherent capabilities of the original Higgins boat. Current military doctrine confidently presumes the feasibility of deploying combat personnel and essential vehicles directly onto potentially hostile beaches at precisely calibrated intervals, a foundational assumption that only became a practical reality because a singular, visionary engineer in New Orleans resolutely refused to accept the notion that such a feat was impossible. While major conflicts are undeniably triumphed through the overwhelming might of armored vehicles, advanced aircraft, and the unwavering valor of courageous service members, occasionally, victory is secured by what amounts to an augmented swamp boat, albeit one equipped with a revolutionary ramp on the front. President Eisenhower profoundly grasped this undeniable truth. It is imperative that all others come to comprehend it as well.